All right, let's see if we can't get ourselves a bracket out of this. Now that we have this part of it down, we know that the peg is perfect. So we can apply the rest of the measurements that I took and see if we can't do exactly that. All right, so I said we go for 1.5 inches wide. So I think we can just do 1.25 inches this way, like that. And then we'll take it to 1.5 inches like that. So now I've got my 1.5 inches of length, or of width, I'm sorry. And let's see here, why don't we use, let's use a box to measure with. Let's draw that in. And let's look at it straight down, because we want to move this to where it is basically centered with our peg. And I don't know, it's looking pretty close to it, don't you think? So we'll go with that, and we'll make that our 1 3/8, like that. So then we know we can take this to even with that, which is right there. And then so if this peg will cover from the light to the top of the glass along this line right here, which means that we need the L, that need to L it and have the L go straight up at the same direction as the peg for a given duration. I'm going to say we'll go with 2 inches just to give it a nice bit of grab. And we can even use this square. No, wrong tilt. Come on. No, just undo it. Turn it to 90. And then okay, like that, and then we'll make it 2 inches high. And that might be a little bit of overkill, but that's okay. I don't mind a little bit of overkill. And let's make sure we got all of our lines on there. I do believe we do. And that looks approximately as thick, maybe not quite. Yeah, so we gotta, because it was a 32nd thicker than a 1/4. So, oh, I know, then an 1/8. So 1 step up from an 1/8, like that, right? 156, 156. All right, so it's the same thickness. So now, assuming that there isn't some major mishap and that decides to print us 2 different pieces, we will have an L bracket with the peg for the light. And I will print off one of these to test it, and if it works, then I'll print off the other one, and then we'll mount the light. And we win. So yeah, we'll save this and run it into Cura. So let's see here. So this is just bracket 1, and it'll be the test for the bracket, not a peg test. So just test for bracket number 1, and we'll export that. Everything in the design, STL, save, and we'll just, we'll drop it right in there with it. Okay, and now we flip over to Cura real quick. All right, so here we are in Cura. So import our bracket. Okay, and then I'm going to do something a little strange with this one. I am going to lay it on its side, and as soon as I figure out how to do that. And the reason why is because of how FDM 3D printers work. It basically draws lots of lines and layers them on top of each other. So for the sake of a more sciencey way to put it, FDM 3D prints have a very obvious grain to them, and that grain, just like with anything that has a grain, like wood or anything, with layers like that, its weakest point is between the layers. So if I printed it in this orientation, okay, all of the layers would be going like this, and then they'd stack up and stack up and stack up and stack up and stack up this way, right? And then even though it would be, the peg would be up on its side 90 degrees. Here, let me see if I can just actually, there we go. So let me rotate it. There we go. So if I set it in there, so it'll be sitting here like this, and if all the grain is like this, right? And then, and like this, when the weight is on it, because the weight will sit against it underneath, pushing up, and so with the grain being like this, all that pressure will be put with the grain, which means the space between the layers will be taking stress directly, whereas if I lay it like this, right, then, let me like this, so now all of our grain goes this way. So when the light is hanging on it, it is, the pressure is going against the grain, so it's not putting stress in between the layers, making it easier to break. It will actually be stronger this way. And I'm sorry if that's a horrible explanation. It makes so much more sense in my head. But so printing it this way will give us a stronger result. The problem with it is, though, is that peg is now kind of hanging out in the middle of nowhere. And so we need to be able to make sure that prints in place. So what we're going to do is click this right here, which is Enable Support. And let's see. Okay, so we just need it to touch the build plate. It doesn't have to go crazy. So I'm not sure whether or not it's going, I don't know if we can get a preview of what the support will look like, but it should add little, you know, under this area here, like right under the peg in the open space, it should give us, it'll build up a layer of a little bit of plastic so that when it starts to print the peg, it has somewhere to start from instead of open air, and that means that our peg will be built without problem, and we definitely want that. So I'm going to kick the layer height up to 0.3 millimeters, because with the layer heights being thicker, means more plastic means stronger, or should. I'm also going to increase the thicknesses here from 0.6 to 1. To also make it stronger. And then we will change the infill percentage from 30, and I'm going to go with 75%. Let's see, and then look at what it has done to our build time. It only increased it a couple of minutes because it's not real big, but see now, you know, the test was only like 13 minutes, and now we're looking at like, the test was only 15 minutes or so, and now we're looking at close to an hour for this. So, you know, the bigger the build, the longer it takes. So yeah, like that layer height, like that wall thickness, like that infill. We're still using the same PLA, so all of that stuff stays the same. It seemed to work well with that print speed and travel speed, so we'll leave that alone. We've got the support going, and we'll just do the skirt, that's fine. And all right, so this is it. This is our full-on test, and we'll see if that actually will hold the light on the glass. Well, in an hour after it prints. So let's see here, do I have the right memory stick in? I sure don't. Okay, so yeah, once I get the memory stick in, which I will do here in a sec. Okay, now I have the right memory stick in. So we got test for bracket 1. So we got test for bracket 1, which is perfect, and we'll save that. Okay. And let's go to the printer. All right, so the 3D print is done. You guys were lucky you got to watch the fast version, where I had to figure out something to do with the just over an hour it took to print. By the time the bed heated up and all of the things took place, it ended up being like right around an hour and 10 minutes to print. But, oh, where did it disappear to? But the print is done. It looks really, really good. It's nice and rigid. So we'll break away the supports for the peg and see what happens. All right. So yeah, the support. So this is the support piece right here. I don't know if you can see that or not, or how well you can, but it should break away pretty easily. Look at that. No problem. And yeah, no, and I don't think it's going to be an issue either. So first off, let's see if the peg still works. Okay, so I had to force it, but it goes in. And Okay, and it does go into the teeth as well. Holy moly. Okay, so that's good. That means it's not going to come out at all. So, no, that's good. And then, so we'll test it. Does that fit? Nope, doesn't fit right there. Doesn't fit right there. Yes, good enough anyway. Okay. So, cram it on there. Shove it down that. And okay, so it ended up a little bit long, but it does hold it. I don't know how well you can see that, but I mean, it does keep it there. But there is quite a gap. I'm wondering how much. Yeah, I overshot that by quite a bit. I'm curious as to how that happened, since the measurement was exact. I mean, it was from the middle of the keyhole to the top of the glass here. And that's not a perfect example, but from there to there was the 1 3/8, and that's exactly what I gave it there. Let's see here, did it misjudge? Let's see what we've got. No, it is pretty well straight on. So I must have missed something. Either that or I didn't get that centered just right, because it's got about a 1/16 of an inch too much. But I don't think that is enough to deter me from using that. Like, I think we're going to call it a win, because it will be wedged in behind the wall, so it'll sit like this, and then the glass will be here, and then the wall will be right behind it, so it won't have anywhere to go. So even though it's not perfect, it is close enough. I mean, and it is too. It's just barely, like I said, like a 1/16 of an inch too much slack. But that is something I can live with, because I mean, like I said, I mean, just the one holds it in place. So yeah, I'm going to print out another one of those and call it a win, because then I won't have to worry about it being stuck, and I can take it on and off very easily. But these will stay in place really well, which I like. So not a perfect win, but still a win. So